Namaste.
And welcome to Context Free, where we talk about programming languages. Today I want to talk about multi-line strings, somewhat motivated by the recent support for them in Java 15. And in this JEP, they have some examples. You might want to embed HTML or SQL, or perhaps some JavaScript code for a scripting engine. You might also want to embed natural language as well. And let's take a look at code, starting with C++. The string literals I'm using here so far are also compatible with C. And in Java, where you might use plus to concatenate strings together, in C or C++, when you just juxtapose string literals and put them together, the compiler treats it as one long string. So if I embed new lines in here, I can make a multi-line string with a relatively nice syntax. Depends on how much noise you want to see in it. I can also use the same feature to embed binary data. In this case, a 1-pixel transparent GIF, which I originally got from this web page. They gave it to me in Base64. Let's run this program and see how it does. And I piped it through sed to replace all end lines with pipes so that we can see if there's trailing white space. In this case, we don't see it. It's relatively clean. And all I'm outputting for the binary data is just the length. That's a simple enough check for our purposes today. And because I made it a char array instead of a pointer, size of works. And I subtract 1 for the null char at the end. Now, in addition to this syntax, C and C++ also support multi-line strings. They look different. Let's start with a double quote and end with a double quote. Get rid of those. And these as well. Let's put a backslash on the end instead. Later backslash here too. And this is how you can span a single string literal across multiple lines. This backslash also prevents a new line, which is why I left the new lines in place. If we run it, we still have our multi-line string, but it's been indented because while the new line doesn't apply, the remaining indentation inside of the string does. And you may or may not care about having this extra indentation inside of your string content. Now, beyond these string literals supported by C, C++11 also introduced raw string literals. Let's take a look at that. In this case, we put an R in front and an open parent inside. We need to get rid of our backslashes, but only the new lines from the other lines. And we also have to end with a closed parent. Let's see what this does. It looks about as before, but it has the extra new line from the front. And if you note carefully here, I had embedded a \t just to see what happens across the different languages. And inside of these raw strings, the backslashes now are taken as raw. And I may or may not have wanted that \t to be unescaped in my program. There's something else to watch out for perhaps as well. Say we had accidentally or purposely included some trailing white space. That includes a potential indentation I already had here. I can't see it in my program source visually, but it's definitely there and affects the output of my program. So for today, let's turn on white space so we can see the effect. These kind of decisions might impact your programming language design as well. And finally, note that raw strings have potential for problems. Say for some reason I wanted that to be a string instead with an embedded close parent. All of a sudden, my close delimiter for my string doesn't work anymore. And C++ have the ability to control what your close delimiter looks like. In traditional shell scripting or Perl or Ruby, it's often called here docs. Whatever word I put in here has to match on the end to terminate the string. And a lot of the languages we look at today have ways of doing this, but I won't necessarily demo all of them. One other thing to consider is what if I did want that \t escaped for some reason? In this case, I'll have to end my outer literal, start a new one, and rely on juxtaposition. Now I have a tab character back in my output, while using raw strings otherwise. Let's move on to Python. Python has popularized the triple quote for multi-line string literals. And for binary data, I want to distinguish it from Unicode strings, so I put a B in front. Let's run this. And we see our indentation, as well as trailing white space, are included in the output. And the \t is rendered as a tab. If I want a raw string in Python, I prefix it with an R like usual, and otherwise things stay the same. And furthermore, while I can do pluses to concatenate strings, it supports the same syntax as C and C++, where juxtaposed literals count as a single string. And for my multi-line string, if I want it dedented, I can explicitly call functions to do so. And now it looks clean, which may or may not matter. If I were embedding Python instead of JavaScript into a scripting engine, I might want to pay close attention to how the indentation looks. And for the meanwhile, I'm indenting by 2 spaces because that's common for JavaScript, but in an outer language where I'm indenting by 4 spaces. So VS Code tries to infer that I have 2-space indentation, which makes my editing harder. So I have to figure out how to convince it otherwise, or change how I indent my embedded code, which I may or may not want to do, depending on the circumstances. And finally, before I go further, I want to emphasize the relationship between multiline strings and multiline comments. For our API documentation in Python, we use docstrings instead of comments. And these can become rather involved. So for example, in NumPy here, we have a big long documentation for our zeros like function, where indentation matters to some extent as well in communicating the information. Let's take a look at Java now, where we see again the idea of API documentation, where we might want indentation inside of it. And it's a multi-line string, but not for string data in the program, but for humans to read, or possibly extracted by, for example, the Java doc processor. So we should keep in mind the relationship between comments and strings as we go along. But here we are in Java with our new text blocks, and we can't run it yet because we have errors in our program. This is a fake error that says I need source level 15 activated in my editor, which took enough effort to do, I didn't bother with it. But down here's a real error because hexadecimal escapes for 8-bit bytes don't exist in Java. You do get 16-bit Unicode escapes, however. So let's try that instead. And since it's all hex now, we can't see our cute GIF string inside of here. And we have a couple of different options. One is our old-fashioned string concatenation. And our other option is the new text blocks, where here I'm taking advantage of a trailing backslash. And unlike in C and C++, when they're trailing backslash, the leading indentation for the next line doesn't count. So these two strings represent the same thing. And here I've made use of these 16-bit characters to store 2 bytes, which is a bit abusive because these might be invalid Unicode. But Java doesn't seem to care. On the other hand, a 43-byte array is hard to represent in pairs of bytes. So I really cared I'd have to worry about how to express that I didn't want that last byte. But let's run it anyway. And we see those 44 bytes now instead of 43. But something that's cool is up here for our text block, we don't have any extra indentation. We don't have any trailing white space either. Java text blocks ignore both those things, and they infer your indentation level based on what you've done here, which means Java is now a partially indentation sensitive language. If I get rid of this part, everything is now indented further because this now is the left side of our string literal. And before we move on, let's look at the binary data a little closer. To interpret this, I wrote a function that converts the string into an array of bytes, separating the 2 bytes. But that has its flaws, as we saw. I could make an explicit byte array, which has different pros and cons. One of the cons being that I have to explicitly cast anything that's value 128 or higher, because everything in Java is signed, and it says that can't normally be a byte literal, so I have to convince it. But if we do this now, we do have our 43 bytes again. But really, none of these are really great in Java. What makes more sense is to load a separate file as a resource. This is a runtime operation, though not terribly inconvenient. And if we look here, we see that we have a file there. It's 43 bytes long. If we run our program, we get 43 bytes. And since Java is usually shipped as jar files zipped together, this would pull it out of the jar file and not treat it as a separate file in the way you ship it around. Though I do get curious if any ahead of time compilers try to optimize this into just embedding binary data into an executable. Having seen Java, let's take a look at Swift, which Java seems to have been quite a bit inspired by in how it made its text blocks. Here we have our triple quote again, popularized by Python, although done differently in Swift and Java than in Python. And just like in Java, making a binary string array is not very easy in Swift. So I just made a simple uint8 array. And because it's unsigned, some things were simpler here. If I run this, it works as expected. And the indentation is gone, just like in Java, although it kept the trailing white space. And interestingly, Swift cares how you indent your empty lines. If I get rid of just a partial indentation, I get an error message. If I get rid of all of it, I'm good again. And personally, I don't like white space on my empty lines, so I'd probably go it this way. Let's take a look at ECMAScript/JavaScript, although actually in the form of TypeScript here. But the features I'm discussing here aren't really related to typing at all, although I'm also using JSX, which is non-standard. And so for my multi-line string, I'm using these backticks, but also, like I said, I use some JSX here to see what happens with my multi-line string content there. And finally, I have a binary array again, which I chose to convert from a string into a uint8 array. Let's run this. About 43 bytes at the bottom, and a multi-line string at the top, where the indentation and trailing whitespace are retained. On the other hand, for my JSX literal, a lot of the whitespace is removed. I had to escape my curly brace, which I did here as an XML hex escape, but I can also embed any JavaScript expression I want inside of curly braces, which is why I had to escape the curly braces in the first place. And so it created an array of 3 strings, one for my content before my expression, one for this expression, and one for everything afterward. And leading and trailing whitespace is entirely deleted. And within any of these individual string contents, new lines and any other whitespace are replaced with just a single whitespace, following HTML conventions. So perhaps if you wanted to use this trick and were using JSX, you might consider this more for natural language. And just like this can be used for arbitrary expressions, making this a text template of sorts, the backticks in ECMAScript also create a text template. So I can embed whatever kind of expression I want in here. And one of the main reasons you might want extended text data inside of your program is to make a template out of it. But we're not going to get further into that today. But finally, in JavaScript, where load time is often queen, we might want our program as small as possible. In C++, this gets turned into bytes in the executable. But in JavaScript, we ship source. So to make our source smaller, we might choose instead to use the base64 encoding. Might depend on whether you're optimizing computation time versus pipe delivery time. Let's look at Ruby next. Ruby is the first language we look at today that just simply lets you make strings with new lines inside of them. We can also use strings for binary data, and I chose to make an array of them and join them before converting to bytes here, instead of using concatenation operators. Let's run it. Works as expected and happens to retain indentation and trailing whitespace. But just like we saw with the here doc notion in C++, I'm going to demo it here as well. And it's more from languages like this that the word here doc comes from. So again, I can choose whatever string I want and terminate my string with that as well. So I can choose something very unlikely to, or that I know doesn't appear in my string content. Works as before, although now no longer has that new line on the end. And I had to keep it dedented for this to work. To allow an indented terminator, I put a dash in there. And conveniently, Ruby also has the ability to handle the indentation of the string itself by using a tilde instead of a dash. Now we have our clean string content, although with the trailing whitespace. Let's look at Rust, which also allows arbitrary new lines in your string literals. And we have a couple of options for our binary data. We can use B to indicate a byte string instead of Unicode data, and we use a backslash to continue our string across multiple lines. Although unlike in C and C++, when you have a backslash in Rust, it ignores the leading whitespace on the next line, just like what we saw in Java for the text blocks there. Run our program, we get as expected, although indentation's kept, as well as trailing whitespace. But really, just like we had in Java, maybe we don't think it's best to include our binary data directly in our source. In this case, we have a macro include bytes that lets us reference an external file. But unlike Java, that has semantics of loading it at runtime, this right here explicitly has semantics of embedding the binary data at compile time into our executable. And if we look at our executable, we'll see that it has this GIF data inside of it. We can look at raw strings in Rust as well here, but I'll skip it for today. Instead, I'll take a quick look at the use of a third-party macro in doc. That allows getting rid of our indentation at compile time. So for languages that have macros, this might be an option. Having gone from RB to RS, let's go now from RS to PS, which is a completely unrelated language, PostScript. If you know what PostScript is, you probably think of it as a way to describe visual page data, like a document format. Today we usually use PDFs instead, but PostScript predates it. The graphics model is much the same, except PostScript is actually a programming language, a concatenative one, where your operations follow the data they work on. Here I define a main procedure by giving it a name, and here's the actual procedure definition, and I define it. I can also give a symbol for a text variable, a string literal surrounded by parentheses, and define it. I can reference that and print it. I can define some binary data with a hex literal, define it, then reference it, get the length, and print it out. Where equals is like print, but supports numeric and other data types as well, not just strings. Let's run this. And we'll just use the command line for now. No fancy graphical documents. And we see here our indentation and trailing whitespace are kept, and the \t is turned into a tab character. And I find this hex data interesting as well. If we are making a document, we might want to include images, for example. So you might expect there are ways, and this is one of them, of including binary data. This literal treats all of your content as hex numbers for bytes, and ignores all whitespace inside of here. But relative to string literals themselves, what's interesting is that the delimiter is parentheses, but it can also contain nested parentheses because it knows to look for nesting. If it matches these up together, it knows the outer string hasn't ended. If for some reason I put in an extra closed paren, however, then the world falls apart, and I would want to escape it. And by the way, you might think of PostScript as sort of being like if web pages were delivered primarily by JavaScript rather than by HTML, only for paged graphical documents. Let's move on to Odin. Odin, like Go, uses backticks for multi-line strings, but these are raw strings, unlike the templates of ECMAScript. And we can also embed binary data, although certain parts of Odin expect this to be UTF-8, so pay attention to that. And let's run this to make sure it works. It does, retaining indentation and trailing whitespace. What I want to focus on here is again the relationship between strings and comments. Anyone who's familiar with C-style syntax might worry about this. You can't nest your comments in C, but while this looks similar in some ways, in Odin you can nest your multi-line comments. If I got rid of that, I now no longer have enough matching pairs. These go together and the comment isn't terminated. Which reminds us a little bit of the nested parentheses for strings in PostScript. And to look at a completely different perspective, let's see Zig. Zig has no multi-line comments, and the way it does multi-line strings reflects that as well. You never need more context than a single line in Zig to tokenize your program. To parse it into a tree, yes, but to tokenize it, no. So there's only single-line comments. And your multi-line strings look like single-line comments, only reverse the direction of your slashes. And they just go together into a single multi-line string. Let's run it. And we see our indentation isn't present, which we expect because we can see where our string starts, although the trailing whitespace is still there. If we wanted to handle the \t escape, we'd have to break up this line into a different kind of string and use the compile time string concatenation feature. And in Zig, just like in Rust, I could use string concatenation to embed binary data, or I can just use the built-in function embed file that at compile time puts that binary data into my program. You might have build tools for JavaScript or C++ or others that'll do this for you, but it can be nice to have this supported directly by the compiler for the cases where you need this binary data in your executable. Anyway, I hope this has been fun. Maybe we can look a little bit more at text content and embedded data in the future.
Punah milama.
/*, the woods are lovely, dark, and deep, but I have promises to keep, and miles to go before I sleep. */ blank. / the woods are lovely, dark, and deep, / but I have promises to keep, / and miles to go before I sleep.